So now that you've learned about some of the basic operators in the Flux class from Project Reactor, let's turn our attention to some other operators that are used to get these things to run asynchronously or concurrently or in parallel, whatever you want to call it, which is really the purpose of all this stuff, to get things to be asynchronous. And to do that, we're going to talk about some methods called subscribeOn, publishOn, and scheduler's newParallel. So subscribeOn and publishOn are both methods that are going to be part of the Flux class, but they're going to use a scheduler, and the scheduler we're going to look at here is scheduler's newParallel, which is a factor method that returns a parallel scheduler. So let's talk about the subscribeOn operator first. Some of this will look a little familiar to you because it's very similar to what we saw with mono. So what subscribeOn says is run subscribe, unsubscribe, and request on the specified scheduler parameter. And the scheduler parameter is passed as a parameter, of course, and that indicates what thread to run the operation upon. And it returns a flux that will request asynchronous processing. As we talked about with mono, the semantics of subscribeOn are a little bit weird, right? It's like a square apple or a square orange. It's not what you'd expect sometimes. And in particular, what happens here is where you place the subscribeOn operator in the chain doesn't really change the semantics of this, given other things being equal. And let's assume that there's no use of things like publishOn, for example. So here's an example where we're going to use subscribeOn, and it's going to generate numbers from 1 to S max iterations in a publisher thread. You can see the publisher thread is going to use the newParallel factor method we'll talk about here in a second. So we're going to publish this thing on the publisher, and then we're going to go ahead and essentially generate a random number. We're going to generate n random numbers, basically, using this technique. And then we're going to subscribe, and it's going to do stuff and send this data up the stream. And there's some other stuff here we'll talk about later when we get into what do finally does and so on. But it doesn't really matter whether we put subscribeOn here or if we put subscribeOn there. The behavior of this chain, this pipeline, will be the same. It'll run in a background thread that comes out of the publisher scheduler. Now, that's the case where I said all other things being equal. You can also have other behaviors if you have a publishOn appear somewhere, and I will talk about that later. Don't worry about it now. I'm just giving you a heads up that subscribeOn's semantics can be overridden if publishOn appears somewhat down the path, because then that's where the code will run from that point onwards. That's a little bit wacky, but that's just what you get with the reactive streams frameworks we're dealing with. RxJava has a subscribeOn that works exactly the same way. Now let's talk briefly about the publishOn operator. It's actually got simpler semantics, and it's going to run the onNext, onComplete, and onError methods or operators on a supplied scheduler parameter, which you can provide. And it returns the flux that's requesting async processing. Mercifully, publishOn semantics are a little bit more straightforward than subscribeOn's. Although, honestly, once you understand subscribeOn, it's not that hard. You just have to remember it. It will have effects both above and below it often. So the way that publishOn works is it influences the threading context where the rest of the operators in the chain below it will execute, up until you run into another publishOn, which you may never run into, but if you do, that then takes preference. So what we're doing here, this simple example, is going to create a stream of data asynchronously using the technique that we just talked about here with this approach. This is actually the code that is generating the data. It's the publishing code. And then over here, what we're going to do is the create method is going to create this stream of basically big integers that are coming from a background thread. And then once the subscriber gets it, it's going to then do the processing of that stream of big integers in a different thread. So this is classic kind of producer-consumer style concurrency, where you've got one thread that's producing data and then sending it up to another thread that's going to consume it. So producer-consumer, publisher-subscriber, and so on. And in this particular case, what it's going to do is it's going to check to see if the number is a prime number and do some stuff with it. publishOn says, I don't care where the concurrency was coming from before. At this point, and from this point onwards, it's going to run in this thread context, which is another, in this case, it's another scheduler context with a single thread. It's got the name subscriber, and that's where the processing of the big ints will come. So we have one thread that's generating big ints, one thread that's consuming and processing. And we'll look at that case study when we get to the case study part. And of course, if for some reason you add more publishons, then they will override what happened before. So you can publish on and do all kinds of crazy things. This particular example is kind of fun because notice I changed from a single thread in my parallel thread pool to 2 threads in my parallel thread pool. And now this publish on will take place in one thread, and this publish on will take place in a different thread. So with very, very, very little work on my part, I can now have a pool of threads that are processing this stuff, and it's very clean and very neat. Now, is it a good idea? That's another story, but it's easy to do. So if you convince yourself you need, this sort of pipeline-like publisher-subscriber model, you can do it with very, very, very little programming effort on your part. But as I say here, beware of publishing on too many different threads. You can end up with a lot of overhead because threads are not for free, at least not with traditional versions of Java. Maybe modern Java with virtual threads get you closer to threads that are free. The interactions between publish on and subscribe on are rather convoluted. I am not going to attempt to explain them all. Mercifully, you don't have to know that much in order to do the assignments, but if you're ever curious what the differences are, you should read this link and it will explain them in full-blown glory, and your brains will melt because it's very complicated. RxJava has something called observe on that works the same way as publish on. I don't know why they had a different name, but they did. And like I say, it's a mystery as to why they named them different things. There's a bunch of stuff like that between the two frameworks where you just figure somebody got up in the middle of the night and said, let's just change the names just to throw people for a loop, So let's briefly talk about the newParallel operator. This hosts a fixed-sized pool of single-threaded executor service-based workers. So it's a pool of single-threaded workers. So it's a pool of things. It's a pool of threads. And you can give it a name like publisher or subscriber. That's just the name it's going to be known for. And that's the name it's going to be used when you print out the thread name. It'll be that name. And you can also indicate how many threads you want to be pooled in the fixed-sized pool. And it returns a new scheduler that's suitable for parallel computations. And interestingly enough, if you try to use this for blocking APIs, it will throw an exception, which is a little weird, but it's intended for non-blocking operations. We typically use this method to create custom parallel thread pools, or parallel pools that have at least one thread. So here's an example which we'll look at when we get to the case study part, where we create a publisher, which is a scheduler that has a name publisher and one thread in it, and we use newParallel as the factory method to make that particular publisher, and then we use that publisher down here to indicate where we want this computation to run. This is interesting. newParallel is not implemented using a daemon thread. And the word new is the indicator, it's the indicia to get that point across. And as a consequence, your program will not exit until you correctly dispose of this scheduler. And how do I know that? Because I got it wrong the first time I did it. I used this technique and I ran my program and I'm like, why isn't it terminating? And I was like, of course it's not terminating because new publisher doesn't make a daemon thread. So it wants one that's going to be disposed. And we'll talk about this later, but this is an easy way to dispose of something. So you can see that we make the publisher up here, and then we have our little chain, our little pipeline of Flux operators, and we use the do finally action operator. I haven't really talked about do finally next. I probably should have talked about that earlier because now we're covering it a little bit. But do finally is basically, it's kind of like a destructor. You can think of it as a destructor for a Flux pipeline, a chain of Flux operators, and it's going to be called when we're done. So it's like a hook method. And what we do here is it says on the finally, when we're finished, no matter how we finish, whether we finish because we completed or because we completed with an error, we completed normally, whatever, however we finish this pipeline, call this method and we say publisher.dispose, and that basically deletes that. So the question is, does the do finally hook method get called before or after the onComplete method on subscribe? That's a really great question, and it gets called after. So what happens here is everything's finished, everything's done. we've gotten the results, it shut down, it hit end of file, the moral equivalent of end of file. And then just before we get rid of this entire stream, do finally's action gets called, in which case it'll delete things. So it's what you want. It's the last thing that happens. But that's a great question. RxJava does not have an equivalent method to this. Its schedulers class doesn't have an equivalent method. However, you can use the from method, which is part of RxJava, in conjunction with Java's executor framework to get much the same kind of behavior. You can make your own thread pools with whatever size you want, and so on and so forth. So there's ways to get the behavior. They just don't have one that's called newParallel. And here's some examples of things you could make with from. You could make with RxJava's schedulers from factor method. You could make a fixed size thread pool, a cache thread pool, a work stealing, fork join pool, et cetera, et cetera, et cetera. You can make all those different. So that's the end of our discussion of concurrency and scheduler operators. Now that we know about those things, we can start to write much cooler asynchronous programs using Project Reactor or RxJava for that matter.